Hello, Namaste. I'm back here with the next set of lectures, which I promised in the previous class that I would start looking at how we'll graduate to look at the software part of this particular course. So, here in this, though it is GIS data quality, I would be looking at how do we edit the data, what are the different the transformations that we would see, and how do we actually edit the data in terms of getting a good quality data. What kind of editing is necessary, what are different editing tools, that is what we will see in this particular set of slides. So, in this particular presentation or lecture, I would look at the thematic layers. What do you mean by a thematic layer? Then what do you mean by spatial data editing? Okay. So, editing, correction errors and also omissions if in case there are certain errors. Then we would look at topology, how a topology is actually created. Topology is extremely important in terms of your data handling, then transformations that may be there in your entire data set, then editing an attribute data. How do you edit an attribute data? Why do you need an editing of an attribute data? So, all of these would we will look at in detail in this particular set of slides. Okay. When we look at thematic layers, probably in my previous lectures I have spoke about this thematic layers. Yes, these are different thematic layers of land use, transport, CDP, water bodies. So, each of these are thematic layers. Why are these called a thematic layer? If you ask me, then for example, let us say that this is one layer of land use that I have referred here. So, now I have produced a theme, which means that it is representing a certain set of representative values which are easily visualizable. That is nothing but a theme. Now, if I have red in that particular data, if in my legend red refers to urban, in my legend that green refers to vegetation, blue refers to water body. That is what is called a thematic layer. We are representing a theme based on that layer, the data that has been generated. Okay, so that the visualization is easy, the identification is easy, and it is easy to convey message to the people or persons or to the organizations in a much easier way rather than writing it in terms of a text. Okay, so this is what is nothing but a thematic layers. Now, when we look at any of the database, it will have several layers in terms of separate data files. Each of these layers will be stored as a separate data file. So, when we are looking at these layers, it may contain object type intended to be processed together. I mean, when you have 2-3 layers, this may have different entities which are supposed to be processed together, or it may have points in one layer, line in the other layer and a polygon in the third layer. Okay, that may also happen, and so on. So, when you are looking at this, when you want to process, for example, you have collected only point data in a single layer, and you have collected line data in a single layer, and you have collected a polygon data in the other layer. So, you did not want to mix up when you are looking at the field data collection. So, but this has to be processed together. That is where your thematic layers representation becomes extremely useful. Okay, for each layer also, if we consider that each layer has subsidiary layers for national, country, urban and private roads. This is another assumption that, for example, I am making. Now, collecting logically similar objects can reduce the amount of data required on individual object. Okay, so these why do we, as I explained previously in my lecture, thematic maps is to give you an advantage to understand overlapping objects and to derive meaningful information without having to read the huge text that may be there underneath. So, now if you have so many layers, okay, within a click of a button I can understand where the new proposal of industry has to come just by a query data set, because I have all the layers that is related to that particular city. I have just given a sample layers. It may be another 100-120 layers which had to be generated for a particular city modeling. Okay, so if you look at the entire data set, it is stored in a database which is quite voluminous. Now, with just a query, you will be able to understand, and more importantly, this query digs down, the final map is the sum or whatever the functions that you use, and is output as a thematic map. Now when I get a thematic map, let us say I assume normally the theme to be RGB, R representing the regions that are saturated, and B representing the regions that are normally can have a green field or a brown field development, or let us say green field development. So now I want to find out a region where actually this industry has to come. Now what I do, I can drill down all the data, find out the final map, and just give it a color shades. Now if once I give it the color shade, anyone even without a knowledge of GIS can understand by my representation that the red cannot be used, because I would have put the labels also, that the red are the ways places where no industry or any of the buildings has to come up in that region. For certain aspects that I would have considered, I would have considered the air temperature, the air pollutants in the atmosphere, all of these stuff. But if that the same person can also understand where there is blue, it is the region where the development can happen, and where there is green is extremely the region which is in between blue and red, where it is as sensitive as possible, and the caution has to be considered in terms of map in development. Okay, so this is exclusive of those layers which are environmentally sensitive. So I am not speaking about so if you have a layer of environmental sensitive layer, so probably you can use that also to make a decision. So it is easy to find out a decision. So always the thematic layer representation and the digging down of the data is based on object oriented approach, that is based on geometry and attributes. Okay, I have spoke about this. So when that is about the thematic layer, we'll in our practical class we will generate a thematic layer. I would suggest everyone, I have already requested you guys to download certain data maybe from Bhuvan, and try to digitize that data if possible. If not, when we start looking at the practical class, I would also send out certain notes as a part of this practice class, wherein you can look at each and every step to address every issues that are that we have already spoken in terms of this subject. Now the next concept that we are looking at is spatial data editing. The spatial data in editing, when I say, people think that I am editing some data to add in my the information. It is not just that. It is about, it involves updating and removal of errors from the existing GIS maps. So please be careful here. I am not manipulating any data in terms of the data to whatever I need. It is about updating a data or removal of errors. So that is extremely important. Removal of errors is what we are more concerned about, and data updation is extremely necessary. For example, the data of 5 years old has to be updated today, otherwise you would not know what land parcels have changed to what regions. So data updation is extremely necessary. So normally it is done in two broad categories. One is locational errors and topological errors. So they have two kinds of errors when you are looking at spatial data editing. Especially the topological errors is extremely important in if you are looking at the topology of the space. I will come to that in the next maybe in the later session, later part of the lecture. But when you look at the locational errors, these are due to human errors, while data collection, manual digitization, etc. And these are the errors which also can get in terms of data acquisition, maybe through scanning and tracing of the data, or digitization of the data. Okay, whereas the topological errors are those which violate the topological relationship. So I am not speaking about the topology map here. So when I speak about topological errors, it is because it is based on the relations, the topological relations that are underlying in each of the data that it is related with. So that kind of relation, the correction of those errors is also extremely important. We look at how we will do it. For example, when we look at how do we edit, there are a lot of GIS support packages and functions which we would be looking at it. For example, this is a screenshot in QGIS which is showing you an editable toolbar which gives you an options of how to start editing it. So for example, if you consider editor in QGIS here, you can start editing it. You have a lot of functions that are listed here. For example, supplementing. You are supplementing the data that is already existing and adding in more information. Then you are dividing lines in case there are certain errors with that. Then you are moving a data from one table to the other table, or you are deleting one data to the in case you have certain errors. So copying certain data, rotating in terms of the entire polygon set or a line set, then joining lines, then altering forms. So these are different ways of looking at editing. These are just sample functions that we have represented, but there are huge number of functions wherein you can look at editing, correcting errors, and looking at the omission part of it. Okay, so when we look at some of these, when we really take up the last 2 weeks of the practical sessions, it may be in last 2 or 3 weeks where we look at the practical part of it. We'll teach you all of these aspects. Now when we look at spatial editing functions, for example, you have a function which is called as copy functions. You have certain commands related to it. For example, these are certain commands which are helpful in terms of these functions to be implemented. So let's say there we discussed there may be certain errors, there may be huge errors in terms of vector data creation. So if let's say that I have an undershoot, okay, so what you will do is that you will draw a node, dangle, enter arcs, or move nodes, or clean. So these are the different commands which can help you that in order to connect these two undershoots, or this can be done even with a single click, just by a single toolbox. There may be overshoots that you can see here. There is an overshoot, it has to be here, but this pointer has overshooted till here. So what basically is that is, it first draws a node dangle, then select that particular dangle, delete it. Okay, this extra node dangle will be deleted, then it will be cleaned, so that you don't have any extra line or any line segment that is already there. Okay, so these are certain functions that are there in terms of when you are trying to edit it. So when you really go into this toolbox, you will probably understand what are the different functions and how do you do it. If someone is interested in coding rather than in using these toolboxes, most of these softwares have a support to Python. So you can have Python programming and run whatever the toolbox is there. Just call those toolboxes to the Python scripts and use those toolboxes the way you want to use it. Okay, so that's also possible. So we'll look at some of these toolboxes when we look at the practical part of it. So when we look at the raw data, it always contains errors. For example, closed polygons, then you have certain errors where you have this is a duplicate line segment. Probably someone had digitized it first, but someone who again digitized it, they may have created it. Or it may be this is one boundary that was created first, and this is the second boundary that was created next. So now because it has two boundaries, so it may have a duplicate boundary, or it may be having again two different boundaries in this particular context, which is erroneous. So such errors has to be corrected. For example, you have a dangling node here, you have a spike here, you have duplicate label points. See, the same thing is called as a loop, same thing is called as a knot. You have overshoot here, so you have a node that is not required here, which is also called as a pseudo node. So all of these are errors that are actually there in this particular database. So these errors has to be corrected. For example, omissions are normally corrected by entering the missing data directly from the digitizers. If you are digitizing using your computer, you click on it, double click on it, it opens your edit table, and you start adding the omitted data. Okay, the errors for that also can if there are errors like something is an overshoot, that also you can do just by editing it and deleting that particular overshoot and putting out the node back to its particular location. So this is what I just wanted to say about editing and correcting the errors. Especially this image is a true representation of what different errors may occur. So this gives you a picture in your mind what are the different errors that you may have in your entire data. So these are the errors that has to be actually removed from your data that you may have. Okay, so let's look at the next part of spatial data editing, where for example this particular image, okay, whatever is represented here, you can see here the polygons are not closed. Okay, so when you are actually correcting this particular, you can just double click on it. This particular polygon computation has to be done with this particular node. Okay, so if this node and this node, what is the error that is calculated and this node is shifted here, it becomes something like this. Okay, here also the entire thing is missing, the node is missing, and that is what you do with the error correction. Okay, I'm just giving examples so that you understand what you mean by an editing, how do you edit a particular data. Okay, some more examples of editing. So for before editing, you can see that there are some more shapes here that are actually missing. Okay, so these are the shapes that are added. Okay, if you see this, these are the lines, this particular road is missing here, the roads are missing in this entire region, and the roads are missing in this entire region. So that is what we did with editing of the data. We added those roads into that particular image that we have considered. Okay, this is about the first type of errors. The second type of errors is topology. Okay, when you look at many of those, even after corrections, these images may not be acceptable to the GIS system. Okay, even if you have verified images, it may not be extremely acceptable to the GIS connection, because it lacks the logical connections, logical correctness that has to be there in the entire database. That is missing. That is exactly why you may have an error in such data. So what we will do is that we compute nodes and link automatically to create this topology tables. Okay, so probably when you when you start working on the data, the first thing that you will do is look at the topology, define the topology table. If you have looked at the topology table, then if the topology table is built and if it is correct, then only the GIS system will be able to accept your data in the form that is submitted. Okay, so by creating topology, what else you can look at? If you are looking at in terms of what may be helpful to you, the basic help that you will get is if you can easily look at which are the polygons that are not closed. Okay, if there are disconnected lines, connect it and correct it. Okay, if there are missing or repeated ID codes. So I gave you an example in the previous where you have two codes in the same polygon. So if there are repeated ID codes, also you can delete one of those codes. Then you have one or more missing polygons, polylines, or if there are missing points. So all of this can be easily coded if once the topology is built. So topology gives you exact connections between the relationships and also the logical consistency in both spatial data and also in the attribute data. That is extremely important in terms of maintaining your entire data and the database. Okay, so then there are various other types of editing. So for example, the line simplification is one type of editing, where simplifying line by removing additional points. Okay, for example, if you look at this the example A here that I have shown, okay, you have this particular thing like this. Okay, but when you look at the real scenario, this may be much useful if you have something like this. This is a tolerance that we consider, and with this we add a trend line that becomes your line with minimal nodes. Okay, so that may be that may be used with removing the additional points. And very well known methods of doing this is using a Douglas-Pucher algorithm. Douglas-Pucher algorithm is very well known in terms where you have to do a line simplification. There are also terms called as line densification, which means you are densifying that particular line. So when it is the process of adding new points so that you make the line more smoother, more better in terms of the connecting topologies. So if that also can be that also is one way of looking at the correction. So it is dependent on user, the kind of line simplification or line densification, what kind of thing he needs in terms of editing. So it is dependent on the place, it depends on the data, it is dependent on the user. Okay. Then line smoothing, adding new points to the line so that it becomes more smoother in terms of the mathematical functions. These new Most of these new points are generated through mathematical functions. Then you have transferring features. So transferring features from one to the other, one feature to the other features, and these are useful when you have common boundaries. For example, if let's say I have a polygon something like this. Okay. There is another polygon which is something like this, which is actually representing this feature. So now if I have if I have already created a data for this particular region, or the same region is already filled, instead of having a duplicate polygon here, duplicate line segment here, this feature can be easily transferred. Okay. That is what I define here as a transferring features. So that also can be done in terms of GS data. So these are some of the editing features. The next thing that we have to look at is transformations. So when I am speaking about transformation, I am not actually speaking about transforming the image. I am speaking about certain issues which may need transformations. So spatial data manipulation and transformation actually involves, the first one is coordinate thinning. Okay. The reduction of coordinate pairs required when the data has been captured with many vertices for a line features. Okay. If you have a single line feature, for example, if this is the line feature that you are trying to use, so line feature can be just this. So in case you have a lot of coordinate information in between this, so then you may have to simplify it for better representation. Then this process also reduces the redundancy in data and is normally called as weeding away the data sets, which means that the certain information that are not required for a particular line, okay, you weed away that information or you remove that information, then it's called weeding. Then thinning of coordinates also required in terms of map generalization process of linear simplification. Okay. Linear simplification is required when data from one scale, that is, for example, if I consider it as 1:25,000 scale, is to be used and integrated with the data from 1:250,000 image. So a coarser image versus a high detailed image. So if you are trying to do that, then you need a linear simplification of features that has to be done. So that is one way of transformation. First is weeding it out and looking at the linear simplification. The second method is geometric transformations. So geometric transformation deals with registering of a data layer to a common coordinate system. So I'm repeating it again and again. This is essentially extremely important. This is where most of the students make a mistake. Okay. Rubber sheeting is the most common method used where one data layer is stretched to meet another based on predefined control points. So for example, let us say I have one data layer is here. Okay. Now I know what is a predefined, there are predefined control points. Okay. These are the 4 points for this data layer. Now I'll say that in my other map I have a predefined control point which is here. So what you do is you stretch this map or you tie these 4 points into this location and match it to the other map that is there. That is nothing but your geometric transformation. Okay. So normally, as I defined here, this is called as warping. Warping from one data layer to another, for instance, using in a classified map is very important in terms of matching two data and also correcting the whatever the features that are there in that particular image. This kind of method is normally used. So there are several ways of looking at it. So this is one of the ways of tying it out, using any of the polynomial transformations or any of the other transformations, and you put it into the normal, I mean corrected form. Okay, so this is about geometric transformation. The next thing is transformation to a common map projection. Now, as I said, coordinate, coordinate, common datum, common projection. So these are the things that a spatial data always looks at. So always keep it in a common projection system. So for example, I have let us say that I am building up the urban database. Now I have certain data from Google Maps, okay. I have certain data from OpenStreetMaps, I have certain data from Bhuvan, I have certain data that I have captured it from my own field surveys. There are certain data from Survey of India. There is some more data that I have collected it from various gazetteers of the government sources, and various other district books, census books, etc. I have captured. So now all of these books has to be referenced to a single projection, which means this is how we see a 3D map in a 2D world. The once you project it in a proper projection, then only we will be able to identify the 2D, the points, the entity on the 2D layer in a much accurate way. So when you look at the GIS software, most of the GIS software supports converting one coordinate system to other, one projection to other, and one datum to the other. So these transformations are based on mathematical relationship and describe various map projections, okay. And transformations are digital. Ancillary operations are required when wherever the positional information is not a decimal. For example, here I am trying to this is one example where I am trying to use a WGS 84 UTM zone 43 north, where EPSG code is 32643, okay. So I am trying to transform that into a reference manual into a reference coordinate system, which is WGS 84 43 north and 4386. Okay, this may be represented in a wrong way, but I am trying to transform it into another system of projection. So that is where the other transformation is important. So please, whenever you are looking at it, please look at the geometry of objects in your database, please look at the coordinate system, please look at the datum, and please look at the projections. So if all of these are there, then the next set is how you find what are the errors in your data. Okay, if you are able to understand all of this, then most of the errors, most of the issues in your entire data collection or data manipulation and data handling is solved. Okay, so this is about transformations to a common map projection. Then if you look at this is what I was referring to. EPSG is EPSG code here is 4326. Let me go back. So EPSG code is 4326, and I am using a CRS that is WGS 84 lat long. This is a part of Bhopal. So now I'll convert into a common format, that whatever the format I may need. So what I do is I convert into EPSG code where it is UTM 43 north. Okay, I hope everyone knows that India is above the equator. Okay, this is another common mistake that most of the people do. If I ask where does India lie, it is above the equator or below the equator, most of them say it as below the equator. So it is in the northern part of the equator. So when you are looking at it, you have to especially in this particular projection system, you are referring it in terms of 43 north. Okay, so WGS 84 is the datum that we have used here. So please remember this on how we are transforming from one location to the other location. Okay, so this is just an example to show you that transformation. So exact transformation happens. You can see this is the same data set that has been transformed, and the data is intact. Okay, so then editing the attribute data. So editing tasks are carried out using a standard editing tools, such as a few available even in the word processing. Most of the GIS uses the spatial query language. So we'll also look at spatial query languages in our next slides. Specific GIS commands include commands for changing object thematic codes, switching codes, editing thematic codes containing different text, etc. So these are different the issues in handling the database, which we will look at in the database when I am speaking about the database and how we build a database, how to maintain a database, how to query a database. So until then, let us think about there are tools for editing any attribute data in terms of creating a GIS database. Okay. To summarize this particular class, we looked at thematic layers. Thematic layers is a visual representation in order to understand whatever the data has been developed and what is the output of using certain queries in the entire data set, or it may be the output of certain statistical and mathematical operations. Finally, that is given a color, a color that is respective to its representation. So that in order to visualize, so each color represents a different visual aspect on the Earth's surface. Then spatial data query editing. Spatial data editing is about how we edit data. So what kind of editing is there, where there are errors and how to correct it. We looked at different errors also. Then we looked at topology and topological corrections, topological errors. Then transformations, we looked at coordinate thinning, geometric transformation, map projection transformation, and coordinate transformation. So all of these transformations we looked at. The last part I just I gave you an hint about editing attribute data. So in the next session we'll look at how do we visualize the data. Okay, how do we visualize the data and what are the different objects that you should have in your database to visualize the data. So that is about the map cartographic concepts and cartographic aspects. So we'll look at it, and we'll also look at what are the different ways of representing different objects. The same symbol cannot be used for many, so you need to have different symbol sets for different representation. We'll look at all of these different sets when we come back in the next class. Till then, have a nice time. Thank you very much.